all about matter and the different ways that we describe matter and the different changes that matter goes through. Unit 2, we're looking at measurements in chemistry. So we talked a little bit about data when we were doing our Signs of a Chemical Change lab. So data is just information collected through observation. Now we can group our data into both qualitative and quantitative data. So qualitative data is just description. So that could be color, like my pen is blue. That could be texture, like my shirt is soft. Or temperature, in terms of my water is really cold or my dinner is really warm. We could also be looking at height, if someone is tall or short. Now, the second we add any numbers into that, we have what we call as quantitative data. So I like to either underline the N, like N numbers, or quantitative, people think quantities, which also means numbers, obviously. So examples, we could say height, I am 5'3", or mass, I have 50 grams of salt. There is 20 milliliters of water in this graduated cylinder for volume, or the boiling point of water is 100 degrees Celsius. So all of these numbers, okay, are examples of quantitative data. Now, when we look at numbers, sometimes with what we're going to be working with in chemistry, we're going to be dealing with really, really big or really, really small numbers. And sometimes chemists can be really lazy. And frankly, I don't want to write down all of the zeros or all of the numbers in my number. So I'll write numbers in scientific notation. So what is scientific notation? It is a shorthand way or shorthand method to write really big or really small numbers. So its proper form has two parts. Now I'm either going to write in two different color pens just to show the two different parts. So what we have is a number in scientific notation like 5.0 times 10 to the 7th. Okay. So the coefficient is essentially just my number in front. And the important thing to note about my number in front is it's going to be something between 1 and 9.9 repeating, okay? But the key is we only ever want one number in front of our decimal. I'm going to make a little note here. So only one digit in front of the decimal. So the other portion of this is my power of 10. So my power of 10 in this case is times 10 to some number, okay? So times 10 to some power. And in my example, you'll see it's times 10 to the 7th. So my power of 10 tells me how many places to move the decimal. And in which direction. So when we have a really big number, okay, a really big number would have a power of 10. That is positive. So we have, wrong color. So big numbers have a positive power of 10. And we're going to move the decimal to the right. So, for example, if I were to work with my same example from up here, so if I had 5.0 times 10 to the 7th, what that tells me is I'm going to take this decimal and I'm going to move it 7 places to the right. So I'm going to go 5, 1, 2, 3, 4, 5, 6, 7. My decimal's down here, and I'm going to fill in all of these places with zeros. So 5 times 10 to the 7th is really equal to 50 million. Okay, now the same thing kind of happens in the opposite direction. So if we have a really small number, we have a negative power of 10. And we're going to move the decimal to the left. So if my question instead was, say, 3.5 times 10 to the negative 4. Okay? So what that means is if I start with my 3.5, I'm going to take this decimal and I'm going to move it 4 places to the left. So I'm going to go 1, 2, 3, 4. I'm going to put my new decimal and I'm going to fill these empty places with zeros. Okay? So if you wanted to rewrite this so that you don't have 0.00035, that works too. We're going to do a couple of examples now in the opposite direction. So if I were to have, for example, I'm going to go back up to my big numbers. If I were to give you this number, where maybe I said we have 25,000,000,000. Now, when I first figure out what my coefficient is going to be, I'm going to look at my number, and I'm going to make so that I have one number in front of my decimal point. So this is the decimal point is going to go right here. So my coefficient is going to be 2.5. Now, if I put a decimal here, I want to know how many places do I have to move it to get it to where it needs to go. Because as you know, in any number, we kind of have an invisible decimal point at the end. So, if I'm going to move it, I would have to go 1, 2, 3, 4, 5, 6, 7. I would be moving it 7 places to the right. So we're going to do 2.5 times 10 to the 7th. And what that does is it makes it so that my decimal would be moving 7 places this way. So 1 around the 5, 2, 3, 4, 5, 6, 7. But what if our number was a little bit different? What if I had a number that was, so we'll do another example. Okay. 0.00246. Okay. So the same rules apply. I want to put my decimal so that I have one digit that is not 0, okay, in front of my decimal. So this is where my decimal would go. My coefficient becomes 2.46. Now I have to figure out my power of 10. So looking at this, if I have my decimal here, to get it back where I want it, I'm going to have to go 1, 2, 3 places to the left. So my new number becomes times 10 to the negative 3. So now you're going to work on some examples of this on your own. Good luck!